Two top-tier AI models write flawless code for a retro video game, but when you put their work together, the game crashes. The tasks were split. One AI generated the map layout, while the second placed the monsters. Both models ran their own internal tests, and both passed without a single error. The crash was caused by a direct contradiction. The map generator flagged a specific tile as acceptable for a monster, but the placement logic looked at that same tile and rejected it. The bug didn't exist in either model's individual code file. It lived entirely in the gap between them, a blind spot sitting in the seam of the handoff. Most AI benchmarks today focus on a single question: how well can one model solve a problem in isolation? The entire leaderboard economy is built on measuring the ceiling of individual ability. This creates a blind spot in our evaluation. If a bug only exists in the handoff between two tasks, no solo coder, human or artificial, can catch it if it isn't in their own file. To test a different approach, a researcher took 4 rival AI coding assistants, Claude, Codex, Gemini, and Grok, and put them to work on a single project for a weekend. The setup had no central AI manager and no human dispatcher giving orders. Each model was simply assigned one specific role. Coordination happened through this shared board. It functioned as a post office and a shared memory state, allowing the models to pass notes and contracts back and forth without a central controller. Grok handled map generation, refusing to write code until it had an agreed-upon contract. Meanwhile, Gemini acted as the atelier, handling the basic content generation for the game's items and monsters. Claude managed the systems loop and orchestration, ensuring the different modules work together without acting as a superior officer to the other models. This setup proves that decentralized AI teams can self-orchestrate using shared rules. They can converge on a working result by respecting boundaries rather than relying on a single, all-knowing intelligence. This structure solved the integration bug, that contradiction between the map generator and the placement engine. The experiment included Codex as a dedicated reviewer. Its specific job was to critique the work of the other models. This flowchart shows the breakthrough. Grok's isolated lane said a cell was placeable, while Claude's lane rejected it. The red diamond in the middle represents that contradiction. Codex caught the error because its training lineage and its structural position as a reviewer gave it the authority to view both files at once. The game was fixed because the models prioritized clean handoffs and pure review. This team fitness allowed them to solve a problem that their individual intelligence scores missed. This experiment highlights a different path for the future of engineering and tech labor. Current trends suggest using the most advanced, expensive AI for every minor task, but applying that at scale is economically unsustainable for most projects. We can compare the costs here. Using one massive model for everything creates a high, uniform expense. Routing architecture to strong models and basic text to cheaper ones turns that cost center into a manageable budget. Biology teaches us that ecosystems rely on differentiation to survive. A monoculture of a single species is efficient until a specific threat arrives, causing the entire system to fail all at once. Relying on a single dominant style of AI thinking creates a similar risk. It builds a software monoculture where every part of the system shares the exact same blind spots. The results of this experiment suggest that cognitive diversity is a better goal. Using models trained differently to see problems from different angles provides a layer of robustness that single-model systems can struggle to match. Many in the AI industry are racing toward total autonomy, where human judgment is eventually bypassed and replaced. The team model offers a different ending. As we see in the human-in-the-loop node, the human remains a director, making key interventions at specific gates to steer the project. In this framework, older or less powerful models don't become obsolete. They become specialized colleagues, working alongside humans to carry a project forward. The goal of AI development doesn't have to be a smarter machine that makes us optional. It can be a shared system where different minds coordinate to build things that none of them could finish alone.